Hello and welcome back to Mr. Powers Teaches Algebra. We're in 1.7. We're still dealing with complex numbers. We've defined them thoroughly. We have multiplied complex numbers. We have added complex numbers, which means we know how to subtract them. It's easy. Adding the opposite, right? Or adding the additive inverse. But dividing, we haven't done that yet. So let's do some division. And so dividing these, well, what's dividing? Dividing is multiplying by the multiplicative inverse. Now, with rational numbers, we say it's multiplying by the reciprocal. That's dividing. 3 divided by 7 is really 3 times 1/7. Now, but that's because 7 times 1/7 is 1. So anyway, it's still. We don't need to think about that. Let's just get into some examples and we'll see. Actually, first things first, I got to bring this up again. Can you believe it? You guys remember this whole thing? Get in here a little bit. Do you remember this whole thing where we go like A minus B times A plus B equals A squared minus B squared? Okay, so you remember that? This is going to be very important. And some of you might be thinking, oh yeah, because, instead of A minus B, A plus B, what if it wasn't that? What if it was like a complex number? What if it was A minus BI times A plus BI? What if we multiplied those? And I encourage you to go ahead and do it long ways if you like, but for our purposes, we already know it's the first one squared minus the second one squared. So it's going to still be A squared minus BI squared. This is very, very important information here, guys, because, when we're dividing complex numbers, we want to get a complex number. You'll see what I'm talking about soon. Okay, so A squared, let's just keep going here, minus, let's square this. So we get B squared, I squared, minus B squared, I squared. And what is I squared? Everybody, what is it? That's right, it's -1. A squared minus B squared times -1. What's negative B squared times -1? You got it. It is A squared plus B squared. Ooh. Okay, so this might be information you didn't need. This one is the one you absolutely need. Is that conjugates. Remember, A minus B, A plus B, or for complex numbers, A minus BI and A plus BI. It's the same thing. Those are conjugates. Remember, we have defined these before. We've talked about these. And conjugates, when you have the same two terms, but one has a minus in the middle, one has a plus, you get this nice result. A squared minus B squared is a nice result sometimes. And here we get A squared plus B squared. Still, really nice result. We really, really like that. Because now, we don't, when you do that, you notice what happened? The I went away. There's no I. That's going to be important. Okay, we'll see why. So now that we got that out of the way, okay, that A minus BI times A plus BI equals A squared plus B squared. Now that we got that, that's our big takeaway there. Very, very important. Here, we can even highlight it. Okay, very important there. Great thing to put in notes. Now that we have that, let's take a look at some examples, okay? And when I say some, I think I mean two, because, how many examples do we need? If you want more, of course, let me know. I'm glad to do them. What if we had 3 minus I? For example, divided by 2 plus 7i. What do we do? Do we rewrite this in like a long division form and then go for it? I don't know. Maybe there's a way to do it. We're not going to do it that way. Because remember what I taught you before was multiplying. And I just did this trick up here where you multiply conjugates and you get a nice result. Let's multiply conjugates. Let's see if that works. Let's see if the trick I just gave you is the thing we're going to use. I wonder. Okay, so let's multiply top and bottom by the conjugate of the denominator. So what's 2? Well, let's multiply top and bottom by 2 minus 7i. 2 minus 7i. So what will we get? We know what we're going to get in the denominator. It's going to be first one squared plus the 7 squared. So it's going to be 2 squared plus 7 squared. I'm using this right here. I know that. And the numerator is going to be a big long mess. Should we stop here and talk about why I want to do this? Right now, this isn't a complex number. It's a division problem. It's 3 minus I over 2 plus 7i. It's a rational expression with complex numbers in the numerator and denominator. It is not in itself a complex number. At least it doesn't look like one. We need to show that it is a complex number. So we need to simplify it. Just like we you could say 6 over 3, leave that there, and I say that's an integer. I divided 2 integers. Well, no, I divided 2 rational numbers. It's a rational number. Well, no, I guess it'd still be looking like a rational number. But we'd want to simplify it. In this case, it's not a big deal. Actually, I do have one I could do with the irrationals. But you know what? Let's just move on. We need it to look like this. We need it in this form. Remember what a complex number is. It's a plus bi. That's a complex number. This does not have that form. So we needed to get it in this form. So by multiplying the conjugate of the denominator, we're going to get it in that form. That's what should be clear. So now, let's multiply the top. 3 times 2, 6. 3 times negative 7i, negative 21i. Negative I times 2, negative 2i. And then negative I times negative 7i is plus 7i squared. So it's like division. You notice this, our division is like multiplication with some extra steps. That's all it is. So it's really easy. You just got to remember this trick. Multiply by the conjugate of the denominator. All right, so let's simplify this out. We got negative 21i and negative 2i. The 6 is going to stay there. I'm going to have negative 23i for my numerator. And then this plus 7i squared is really a minus 7 all over. This is 4 plus 49. No rush. I'll just leave it 4 plus 49. And then I think we will keep going. I'm going to go to the right. Let's see here. So 6 and negative 7 combined to negative 1 minus the 23i all over. Let's see here. That's 53. If there's a common factor in top and bottom, we could just simplify it, but there isn't. So here's what we're going to do. This is almost a plus bi, but it's not quite. We need to distribute the 53, the dividing 53. So this is really going to be negative 1/53 minus 23/53 I. There it is. And we have divided it. We have it in the a plus bi form. I know my real number part, negative 1 over 53, and my imaginary part, negative 23 over 53i. Piece of cake. let's do one more example. And this is an easier example, but for some they have a little bit of trouble. So let's do this. 6 minus 9i over 2i. So remember, really the issue is with these is that we don't want an I in the denominator. That's what it boils down to. An I in the denominator will keep us from having the form a plus bi, when that's what we need to get a complex number. This is two complex numbers, 6 minus 9i over 2i. We need to write it as one complex number. So how do we get this to go away? You could say, well, 2i is really the same as 0 plus 2i. So the conjugate would be 0 minus 2i, which is just negative 2i. You could multiply top and bottom by negative 2i. It'll work. It's going to work. Okay, so you could still do the conjugate. But why do all that work when we just want the i's to go away and all you have is an imaginary part? There's no real part. Just multiply top and bottom by I. And as a fun exercise, I encourage you to do both. Multiply by negative 2i in top and bottom, and multiply by I in top and bottom. See if you get the same answer. You will. As long as you reduce at the end, you will get the same answer. Okay, so what do we get here? I get 6i minus 9i squared over 2 times I squared. Okay, minus 9i squared, that's really plus 9. So I got 9 plus 6i, because I'll move that 9 over, and this is 2 times negative 1, negative 2. Okay, and then distribute that negative 2 in. So what I get negative 9 halves, negative 9 halves, and then positive over negative is negative. So I'll say minus 6 divided by 2 is 3i. And there it is. There again, once I got it, a plus bi form, that's my answer. Okay. We got rid of that I in the denominator. Very similar to getting rid of irrational numbers in the denominator. When we say rationalize the denominator, something we did very recently. Very, very similar process. If you'll notice, you compare the two. Very similar. Okay. So that's all I wanted to do with you guys in this video. So until next time, enjoy doing math.